We are now looking at the relationship between math and verbal scores. With this in mind, as verbal scores increase, so should math scores. So let's take a look right here. Well, the relationship is definitely positive, so we can eliminate anything that says negative. Right down here, it should say negative. Oh, that's eliminated. So students with high verbal scores, because that's what we're going to try to use to explain, would typically have high math scores. Verbal explains math scores. X explains Y. Going on further, are there any students that are outliers, something that doesn't fit the pattern? These down here don't really fit the pattern, but this one the most. And they have a very low verbal score and a very high math score. We can go and trace to that point right now. Right here, 800 math score-ish and 250 verbal score. They're the one who fits the pattern the worst. Now, R for this data is 0.5, and that's really great because 0.5 squared is 0.25. Now, R squared is percent of variation in Y explained by X. So 25% of the variability in, let's look here, math score would be explained by the variability in verbal score. That is very key, that R squared is percent of variability in Y explained by X. Once again, remember, when you have R squared, it is percent of the variability in Y explained by X. 25% of the variability in math scores is explained by the variability in verbal scores. Very key. Write that down if you don't have it. Continuing on further, this is where we need our little solver program. So we're going to go over here and bring it up. I already have some stuff in from last time. Do not change these top variables. We're going to change everything else. Now what we have here is the correlation. So let's first get correlation, which was 0.5. Next, we are going to have, let's go right here. Let's check the program. We have the standard deviation of Y and the mean of Y. So Y is the math scores. So we need the standard deviation of Y and the mean of Y. So standard deviation of the math scores is 158.2. And the mean of the math scores is going to be 584.3. If you're looking for this in my class is under, let's show you where it is real quick. Sorry to interrupt. If you're looking for this program, is going to be under projects, not project files. It is going to be under lecture notes. Under lecture notes, regression solver, or you can email me and I'll send you this little program right here. We're just plugging the numbers in. If not, you'd have to solve the equations by hand. It's under lecture notes for my class. Any other class, feel free to email me and I will send this to you. So now we need the standard deviation for the X variable, which is verbal, and we need the mean for the X variable. Let's go back in. So the standard deviation was 138.1. And next we need the mean, which is 531.5. And now we have our intercept and we have our slope. Very important, we can see here that intercept and slope are B0 and B1. So let's go ahead and plug these in right here. We have 279.871. 279.871 and 0.573. And this problem can be a big pain using the equations. We've never really had any students use the equation on the test, but you should be able to interpret this. Right here we have verbal predicting math. Let's double check. Verbal is on the X, math is on the Y. So interpreting this right here would be for each 1 point in verbal, we would expect someone's math score to increase by 0.573. On average, for each 1 point in verbal, we would expect someone's math score to increase by 0.573. That is the slope, B1. Now, the intercept is when someone's verbal score is 0, we would expect their math score to be 279.871. Now, that's impossible, I think, because the SAT only lets you get 200 on each section, and this question was written a long time ago when the SAT was out of 1,600 points. Going down here, we need to interpret. For each additional 1 point in verbal, the model predicts a math increase right here. Make sure we can, has increase and decrease, so it's saying it's going to increase per every 1 point in verbal. And it would increase by B1, which is right here. It's tricky and doesn't give you the number for that, or else you would have it. Predict the math score of a student with a verbal of 449. So let's go right here and put in 449. We're plugging this in as the x value right there. So I'm going to times that by 0.573, and then I'm going to add to that 279.871. I'm just plugging it right in. I'm going to copy paste out of this. That way I don't make any mistakes when I copy it out and put it to the nearest whole number, and we've got it. A perfect 1600 would mean an 800 on both sections. So here you have to use the model to make a prediction. So let's put in that someone makes an 800 on the verbal section. So if they make an 800 on the verbal section, what math score would we predict? I am taking this 800 and putting it in there for the x. So I'm going to times it by the slope, add to it the intercept, and that gives me the prediction. Now the actual is 800. So I want you to think about this. Actual minus predicted. This is going to be positive because the actual would be an 800 math score. So this is the predicted math score. So if we take the actual 800 minus predicted, we get the residual right here. I used the equation to get the predicted, and I knew the actual was 800 to 3 decimal places, and we have it right there. Once again, plug in 800, solve for the predicted, and then do actual minus predicted to get the residual. Going on to the last question right here, we will use jump to solve this. So I would never suggest doing regression or correlation by hand. Always go to these little windows right here, make tab delimited copy. So we have our tab delimited copy, and we go over to a new data sheet in jump, and what we're going to do is we're going to paste with column names. You will need to hit edit, and you will need to go to paste with column names. Now, what can often happen is you will get these things in here right here. We want both of these to be quantitative. This is where Excel comes in. What I'm going to do is I have to go to Excel. I will explain in a second here. I have no idea why this works. It's kind of weird. There's my data. I pasted it into Excel, and now I'm bringing it back over to jump. This is a big workaround. I don't know why this problem has problems, but let's go right here as a motorcycle drives by outside. There it goes. So what I've done now is I've put the data into Excel and brought it back to jump. And I want to highlight the differences between everything right here. The first time I got these quotes in here, and that's going to cause a problem in jump because it recognizes it as categorical. You could try to go in here and fix it, and that can take a little bit of time and a little more explanation on my part. Or you can put it into Excel and then paste it into Excel and then copy it out of Excel and paste it back here. It seems like a lot of work, but it'll get it done properly for you, and what you want to see is quantitative data. So what we're going to use is the age of a car to predict the price of a car. So we can X out this data set that we don't even want and go here to the one we actually need. So let's go to Analyze, Fit Y by X. So with this in mind, we're going to use age of a car to predict the price of a car. And as a car gets older, we're going to notice that the price gets cheaper. And you can kind of see that in the data. So right here we have our regression, but we don't have a line in it yet. Go to the red arrow and go to Fit Line. Now, just like it said, I believe it said the r squared. Did it give us the r squared in the problem? The r squared is 89.3. To get correlation between the two variables, we need to take the square root of this. And for this problem, go to your calculator and type in, let's clear it here, 0.893 and square root it. This is where people make the mistake. This is negative. If you noticed before, we had a line that went down. So go right here, plug it in, and make sure your answer is negative. This agrees with what we see in JUMP right here. Always look at the data first and make sure you understand what you're seeing. Once again, go to your calculator, take the square root, and you will get the right answer, but make sure it's negative since the relationship is a strong negative linear association right here. Explain the r squared in context. It would be 89.3% of the variation in price is explained by age. So age would account for 89.3% of the variation in price. Going on further, why doesn't this model explain 100% of the variability in price of a model, price of a car? And I don't like this question to a certain extent. There are some good answers, I think, for this. What it would be is other factors are going to come into play. And I almost think those other answers are decent enough because different dealers asking for different prices would create something like this right here where you're not going to have the line perfectly explaining all the data. So, if you have any questions, feel free to email me. Good luck.